Now let us move to our set 2 problems. This set 1 is completed. Now we will moving to our set 2 problems. These all problems will cover our amazing concept and quite interesting as well. Let us take first compound, which to understand this kind of CH3O negative. This is actually a compound having in which oxygen is having a negative charge, means it's a charged compound. You can say all these questions contain charged compound only. So let us take first example and understand the concept as well. What's the concept behind this? So our first compound was CH3O negative. Let us take this CH3O negative, or you can write this, the structure I have given, you can write like this: CH3O negative is the compound they have given to us. We have to calculate its DU. So by formula, we will be going by formula. Number of carbon is 1 plus 1 is 2 minus number of hydrogen is 3 divided by. At this point I have to ask you one thing. Can degree of unsaturation be a fractional value? At first sight you will think how it can be a fractional, because we can't have a fractional double bonds, we can't have a fractional ring can't be fractional, and double bond can't be fractional. They are represented like this, and ring is like this, a closed ring. 4 minus 3 divided by 2, that means half, that means 0.5. So it's quite amazing, because this is the compound which is this charge compound actually has been made by like this. Earlier it was an alcohol CH3OH, but what we have done, we have break this bond between O and H and converted it and removed this H and converted into a charged compound like this. Earlier this was an alcohol, and you all know that the DO of this compound was 0. But now since it's possessing a charge, and you can clearly make out that it has removed one H. Earlier 4 H were present in total, now only 3 H are present. So actually DU must change, and it came out to be 0.5. Negative charge, positive charge, or a radical like this will contribute a 0.5 in the DU. So very important concept that negative, positive and a free radical contribute 0.5 in the DU. A point you should note. Now we will be taking some examples. So very important concept that negative, positive and dot contributes a 0.5 in degree of unsaturation determination. Now let us take this question, CH3 CH2 plus. This was our next question in that set. So this type of compound is actually referred when carbon is having a positive charge, as you will be having a bit idea about it. Okay, carbocation. Okay, so when carbon is having a positive charge, this is carbocation, and it's 1 degree carbocation, because with this C is attached, so that means it's 1 degree. If 2C will be attached to this like this, a 1C here, then it will be a 2 degree carbocation. This is a 1 degree carbocation. So let us calculate its DU. It will come out to be 5 hydrogen are present, 2C, 2 plus 1 3 minus 3 4 5, 5 divided by 2, 3 minus this will be 2.5, which will yield 0.5. I have already told you, when you will see negative, positive and a free radical, 0.5 DU will be there. Okay, so that's why 0.5 DU is coming. Let us take other example. Now this is carb anion. Actually, when the carbon is having a negative charge, this is called carb anion. Carboanion. Right. Let us first calculate its DU. It will be 3 minus same, just like this. It will come out to be 0.5. Similarly, a radical CH3 CH2 like this, a dot on carbon. This is a radical group. When you will see a dot on any carbon, and it's 1 degree radical. This was 1 degree carbon ion as it's attached to one carbon. So its DO will also be similar. Okay, so actually this DO is not depending on charges, but it's depending on number of hydrogens and carbon only, because you can see in all the three formulas number of hydrogen and carbon is same, so DO is coming out to be 0.5. You see this charges, do see charges, then you will write 0.5, it's the DO. So let us take some other problems as well. So we have already completed 11, 12, 13, 14. I hope this concept is clear. Now we will be taking 15th problem, 15 and 16. So what's the 15th problem? Let us take that also. Question number 15. So what does question number 15 says? Consider this compound C double bond O negative. We have to calculate its DO. Okay, so directly you can use formula or the concept that we are using for now. Okay, so we will be solving it using basic concept, or now we will not be solving using this formula. You can solve using formula. How we will be solving questions from now is by counting. Okay, I have already told you that a double bond holds a DO of 1. So means due to this C double bond O, DO is 1. Now due to this oxygen, a negative charge is on oxygen. I have already told you, when you will see a negative charge on any compound, assign a DO of 0.5 to that compound. 1 plus 0.5 means 1.5. So that this is a counting method. We haven't used any formula, just we are counting directly. Okay, number of double bonds, negative charge, rings. Okay, we are counting directly. You can what you can do, verify it using, pause the video first and then verify it using the formula that I have given to you. Now let us take 16th problem. It is C double bond O, a negative charge on this carbon. Okay, C double bond O and a negative charge on this carbon. So this structure might look that it doesn't exist, but just I am taking this as an example. So it's DU by the same method. See, since this double bond is present, so it will contribute a DU of 1. Now also this carbon is having a negative charge on it, so 0.5, it will contribute a 0.5. 1 plus 0.5 will again yield 1.5 DU. Okay, now let us take 17th problem. It's a bit big problem. C plus C double bond positive, it's carb cation, C double bond O, C double bond C double bond O negative. Okay, so what are the functional groups that are present? First I will be telling you that also. This functional group in the bracket is actually ester group. Okay, this is alkene, and this was actually carboxylic acid, but they have removed one H so that oxygen gets a negative charge. This was carboxylic acid earlier. Okay, so I will try to give you idea of functional groups present as well, so that you may remember those functional group always. Let us calculate its DU by counting method only. Okay, so a positive charge, start from this point. Positive charge means 0.5 plus C double bond O. This O is of no use, only this double bond is coming here. C double bond O means a DO of 1, since double bond is present. Now C double bond C, this is an alkene, and a double bond, a pi bond is coming here, means a DO of 1. Similarly on this carb, C double bond O, a DO of 1, and this O is having a negative charge, means 0.5. Sum this all, 3 plus 0.5 plus 0.5 is 1, that will lead 4. Okay, so these are questions. Now let us take 18th question. Compound they have given to us. So this is alkene, this is a free radical, and this was a ketonic group and this was a carboxylic group. Okay, this whole was carboxylic group, this is ketonic group. Okay, now let's calculate the DO of this by counting method only. We will not be going with formula now onwards. The DO of this triple bond is actually 2. Triple bonds holds a DO of 2. This free radicals holds a DO of 0.5. I have already told you charged species or free radicals holds a DO of 0.5. This C double bond O holds a DO of 1. This C double bond O also holds a DO of 1, and this O negative holds a DO of 0.5. Sum this all. See, 2 plus 1 plus 1 plus 0.5 plus 0.5, which will yield 4 plus 1 close to 4. So let us move to our two last questions from this set, the 19th question. Both are easy. pH C positive, C double bond O, C and O2. Okay, so this is the compound. This is actually pH is phenyl ring. How this phenyl ring actually looks is like this. It's a benzene ring. It's derived from benzene ring only, and it looks like this. Okay, this is a benzene ring, and we have attached it with carbon like this. I'm rewriting this diagram. I hope you have an idea of this as well. So let us calculate its DU. So don't miss this. Phenyl is a charged species. Phenyl is a charged species. So let us calculate its DU. So first of all, let us calculate the DU of this ring, because we have to calculate DU of this whole compound. Since one ring is present, so DU will be 1, but 3 double bonds are also present inside this. 1, 2, 3. So total DU will be 3 plus 1 is 4. We are following counting method only. This positive charge contribute a DU of 0.5. This double bond C double bond O contributes 1. Okay, and this NO2 group, this is a compound, this is a functional group having 1 DU in itself only. This is all 4 plus 0.5 plus 1 plus 1, 6 plus 0.5 yields 6.5. This is the answer. Simple question. 20. This is a 5-membered ring like this, having a double bond, a positive charge here, C double bond C, CPH, NH2 and PH here. These are two phenyl rings. I have already told you the phenyl rings have a DU of 4. So directly we are using this thing. This phenyl ring will have a DU of 4. This phenyl ring will have a DU of 4. This NH2 doesn't contribute in DU because it doesn't have any DU in its compound. This double bond will have a DU of 1. This ring will have a DU. Now be careful here. This ring will have a DU of 1. Now inside ring a double bond is present, DU of 1, and a positive charge on this carbon means plus 0.5. So this will yield 2.5 plus 4 plus 4 plus 1. This will yield 3.5 plus 8, 11.5. Calculate 2.5. This is 4, this is 1, this is 4 again. So 4, 4, 8, 9, 11.5. These were the questions we have taken. These were all questions that we have taken. In upcoming videos as well, we will be understanding a new method, and simultaneously we will be solving up new problems as well, a bit difficult and bit lengthier ones, just to give you a strong base of this concept. So we will be taking up those problems as well. So keep watching and keep sharing my videos. So and do solve these problems again and again. Okay, these are the base problems. DU has its application in wide variety of organic chemistry chapters, so you should know this concept.